particle accelerator sends atoms smashing into each other at near the speed of light. The collision produces antimatter, the opposite of matter. When antimatter and matter collide, they annihilate each other. Energy locked within the particles is released in a billionth of a second. The reaction produces nothing but pure energy. It's nearly 1,000 times more efficient than a hydrogen bomb, 40 billion times more efficient than TNT. Imagine the power of a weapon which weighs as much as a paperclip and could destroy a city the size of New York. It's a nightmarish vision straight out of a science fiction movie, which is where physicist Professor Richard Thompson thinks it will stay.
Realistically, the amounts of antimatter that have ever been made or could be made realistically in the future is very, very small. And the process by which you generate it is extremely inefficient. It takes enormous amounts of energy and enormous amounts of time to generate any significant amount of antimatter. And to accumulate any significant amount of material that you could weigh would take billions of years.
And keeping hold of it is even harder. The usual way to contain antimatter is in an airtight metal tube called a penning trap. Antimatter particles aren't visible to the naked eye. This trap demonstrates the principle on an enlarged scale. Inside, powerful electromagnetic fields would constrain the antimatter. A similar magnetic force inside this desktop toy keeps the globe suspended.
So the globe is now suspended by those forces, and because of that, it doesn't fall, it doesn't touch the base, it doesn't touch the sides, and that means that if it was an antiparticle, then it wouldn't be touching the apparatus at all.
But if the antiparticle did touch the matter in the walls of the trap, it would annihilate on contact.
The amount of matter that you can put into one of these traps is very limited. The reason for that is that because these are charged particles, they all push away from each other, and that means that the density that you can get within the trap is very limited. The explosive power of that, if you were to convert it entirely into energy, would be just a tiny fraction of the energy that's contained in a match head.
It seems that antimatter, the ultimate destructive material, must remain in the realm of science fiction, for now. The never-ending quest for a bigger, better bang. Of all the world's technologies, few have experienced such a rapid rate of progress. From gunpowder and lethal high explosives to savage terrorist devices and the awesome annihilation of the nuclear bomb. In the space of just 300 years, explosive power has increased more than 100 million times. Now we stand on the threshold of a new explosive age, as scientists push the boundaries of possibility even further in search of an ever bigger bang.